Sir, voice is not audible.
Am I not audible, guys?
You are audible,
You
sir.
are audible.
Audible, sir.
Okay, okay. So someone mentioned this. I am not audible. Thiru. Um, okay. Right. Thanks for confirming that. All right. So, yeah, where is that? Yeah, here is a diagram. Route 53 draw.io. So if you observe this diagram, it's very simple, not so typical. We will look into that complex diagrams also in future. So here, this is an AWS account. Within this AWS account, I'm going to take a private subnet. Within that, I'm going to take an EC2 instance. And I'm going to take a load balance. And you will come to know this public subnet, private subnets and all. Don't worry about that. We haven't discussed yet. Okay. So in simple, I have taken an EC2 instance. On top of that, I have added a load balancer. So then I have configured simple routing policy. Whenever any user is trying to access my domain name, as I told you, I already purchased a domain name called learnaws.co.in. I'm going to use same domain name here. So whenever any user trying to access that learnaws.co.in, the request first will come to route 53. What this route 53 is going to do? It is going to send the request to a backend load balancer.
Recording in progress.
Okay. So the load balancer. Okay, my voice is echoing. Right. So the load balancer have a backend EC2 instance. It have a backend EC2 instance. So the EC2 instance will deliver web page. Load balancer take that web page. It sends to route 53. Route 53 is mapping that web page with the purchase domain name, and end customer is accessing with the domain name. This is what backend architecture we are going to perform. So here we are using only one resource. Couple of EC2 instances, one load balancer, all our resource running in one of the region. Here I'm taking Mumbai region. So whenever we have only one resource to deliver our web page, we are going to use a routing policy called simple routing policy. Okay, simple routing policy is pretty simple. You have web page delivering via load balancer. You are mapping your domain name to the load balancer. That's it. Okay. Whoever opened the browser gave learnaws.co.in, they will get response from there. That is a simple routing policy. The second routing policy is weighted routing policy. For all remaining routing policies, we need to have at least two resource, either it in same region or in different region. So the name only telling weighted routing policy. Weighted routing policy. So if you observe this diagram, we have some resource in Mumbai, we have some resource in Northern Virginia. Okay, this resource is in Mumbai. VPC is defining that, the highlighted VPC. Okay, this is a Mumbai. You see here, it is Mumbai, it is Northern Virginia. I have a web server here, I have another web server here, a load balancer here, load balancer here. But I have only one domain name. I have only one domain name. Now, what my requirement is, I want to send traffic to both the resources, which is running across multiple regions, not just availability zone. One web server is in Mumbai, another web server is in Northern Virginia now. Okay, so how this route 53 will send traffic to Mumbai as well as Northern Virginia based on the weight you configured. Based on the weight we configured. For example, I want to send 100% traffic here, 0% traffic here. We can configure. I want to send 99% traffic here, 1% traffic here. I want to send 50% traffic here, 50% traffic here. So we can change these values in between also. But the important thing is, based on the value we are mentioning, the traffic routing is happening. Okay, in which scenario we are going to use this? Well, see, the simple example is, so in hotels, whenever order comes, they are going to prepare that order, right? And frequently they will get orders. So are they going to turn off the stove completely once order is completed? To keep that pan heat, okay, or whenever any order comes, they're not going to look for matchbox or lighter. They're simply going to increase an existing flame. So a small flame always run. Technically, we call that small flame as a pilot light. Okay, so now my requirement is I want to deliver all traffic to my Mumbai resources, Mumbai region resources. But if something happened to Mumbai, okay, so then what I'm going to do, I'm going to take small amount of resource in another region like a Northern Virginia or Singapore, any region you can take. Okay, when something happened to primary one, immediately I can scale up this. Technically, we call this mechanism as a pilot light scenario, pilot light mechanism. Okay, that is one example for this. Second example is some organizations, whenever they are delivering any new interface or new website or updates for their website, they simply don't push it for everyone. They simply don't push it for everyone. First, they will take a small amount of users or small amount of traffic. They will send to that new interface. They will take feedbacks and all. So then they are going to apply. So now remaining all users, for example, only 5% users need to get new interface. Remaining 95% users should get old interface only. Okay. So how we can? With the help of this. I'm only telling the weightage. Okay, 95% here, 5% here. So we can depend on this weighted routing policy. Okay. This is another example. So one more example for same scenario. You might read about this Coca-Cola. Once Coca-Cola changed their formula and they released a new version, but they have not directly released it to market. They have taken 20,000 people, a specific geo area, and they have released it there. So it's not worked well. So then what they did, they rolled back it. So that's just an example where we are going to try our application. We are going to take feedback. So the percentage we can define here with weighted routing policy. Okay. And you remember, I talked about blue and green deployment mechanism. Blue and green deployment. So same example, I want to spend 90% here, 10% here. Slowly, I want to release this updates to all existing customers, the new interface to existing customers. Initially, I'm going to give 100% here, 0%. I'm going to take 90%, 10%, 80%, 20%. So slowly I'm migrating. So that is also another example for this blue and green deployment mechanism. So to achieve all these scenarios, we can use weighted routing policy. We can define weight in form of 0 to 255. 0 equal to 0, 255 equal to 100. So based on that, you can configure. Right. So that is a weighted routing policy. Now, latency routing policy. The name only telling. The latency will plays key role here. So same website is hosted in India as well as US. One customer somewhere in Sri Lanka and that guy is trying to access our application. So he's sitting in Sri Lanka and he's trying to access. Now, same website is hosted in India as well as US, right? What will happen? The request first will go to Route 53. This Route 53 know where this application is hosted. So now Route 53 will send traffic to this India as well as USA. Which web server is giving quick response? So technically India one will give quick response. So let's assume this is giving 10 millisecond latency. This is giving 30 millisecond latency. That is 10 millisecond, that is 30 milliseconds. So now what happened? This user request automatically will go to this web server. Okay. So basically Route 53 calculate which server is giving quick response for this user. Then all requests will go there. Okay. So that is a latency routing policy. Now, the another one is failover routing policy. This is very simple. We are going to have a primary. You can take one as a primary. You can take another one as a secondary. When primary one is healthy, all traffic will go here. It's like an active passive connection. When active one is active, everything will go there. If something happened to the active one, the secondary one is going to take all the load. But remember, when something happened to primary, then only secondary one will take the load. If primary one is healthy, it won't. Okay. So that's the reason it is active and passive. All right. So that is a failover routing policy. Then we have geolocation routing policy. When coming to this geolocation routing policy, based on end customer geographical location. For example, you are sitting here in India and you are trying to access a website and it will give a message. Okay, this website is blocked in your country. But the same website, whenever you are in different country, they might be allowed. So the website knows from where we are accessing. However, if you are using VPN, no, nothing. That is a different scenario. You will virtually sitting in different country if you are using VPN. Okay, so don't involve that scenario here. If you are directly accessing, you opening a browser and giving google.com. Okay, if it is allowed here, then it will. Otherwise, no, it won't. So based on end customer geographical location, we can route. For example, same website, I have developed in Hindi language or in Telugu language or in any of the regional language, and same website is developed in English language. Whoever is accessing from India, that request should go to this regional language website. And whoever is accessing outside from India, their request should go to that English language website only. But the URL should be same. There is no change in the URL. So how we can configure that? So I'm telling whoever is accessing from India and outside from India, that is a differentiator here. End customer geographical location is a differentiator. Okay. So that is a geolocation routing policy. Right. So this is another routing policy. So we will configure, we have two more IP address based one and multi-value answer. So that is not so important ones. Right. So I'm going to launch resources as per this diagram. Okay, forget about the subnets. I'm going to launch an EC2 instance. I'll make it as a web server. I'll create a load balancer. So then I'll configure Route 53. Got it? Right. So first, let's navigate to EC2. I'm in Mumbai region. You see here, I'm in Mumbai region here. Navigating to instances. Navigating to instances. Launch instance. I'm going to call this as a Mumbai web server. And I'm taking Amazon Linux, T2 Micro. I'm taking a key pair, my Linux KP. And I'm going to choose an existing security group that is opened with port number 80 and 22. We are good with it. I'll do one thing. I'll use user data just to save some time to get connected to it and executing all that commands. I'll use some user data. So this is what the user data. This is my Mumbai web server. Okay, launch instance. So quickly, I'm going to launch it. I'm going to create a load balancer. Navigate to target groups. Create target group. Instance target group as Mumbai TG. Port number 80. Health checks default. Click on next. Okay, the instance not ready yet. include as pending below, create target group. So now a target group created, then I'll create a load balancer. Navigate to load balancer, create load balancer, application load balancer, giving a name, Mumbai ALB is a name I'm giving. Internet facing, I'm selecting multiple subnets here. Security group, I'm going with ELBSC that is opened with port number 80 for everyone. That is important. And whatever the traffic coming on port number 80, I'm sending to Mumbai TG. Scroll down, create load balancer. Very easy, right? You guys familiar with all these things? Okay, so it's going to take a minute or two. So meanwhile, let's go to Route 53. Here I'm in Route 53. It's a global resource. Okay, so go to hosted zone. This is a hosted zone we have. It have 3 records so that S3 bucket one still available. Okay, let me delete that. All right, so now this load balancer, is it ready? It's still provisioning. Meanwhile, let's test this instance output first. Instance